How to Scale Python Applications with Ray, a practical guide. In this video, you'll learn to leverage Ray's distributed computing power to enhance the performance and scalability of your Python applications, focusing on real-world applications and best practices.
Welcome to the world of scalable Python applications. Did you know that most data scientists spend 80% of their time wrangling data and only 20% modeling it? Today, we're diving into Ray, a powerful tool that flips those numbers, allowing you to scale your Python applications effortlessly. Whether you're dealing with big data or high computation tasks, Ray makes distributed computing straightforward and efficient. In this video, we'll explore why Ray is the go-to solution for developers seeking to optimize performance and scalability in their Python applications. Let's get started.
Ray is an open-source framework designed to simplify the process of scaling Python applications. Built on the principles of flexibility and performance, Ray provides a robust architecture that supports a range of distributed computing tasks. Unlike other frameworks, Ray is language agnostic and integrates seamlessly with Python, making it incredibly versatile for developers. Key features include task parallelization, fault tolerance, and seamless integration with machine learning libraries like TensorFlow and PyTorch. Companies like Uber and Amazon leverage Ray to power their data pipelines, demonstrating its real-world applicability and effectiveness. Before diving into Ray's capabilities, let's ensure your development environment is ready. Ray supports multiple operating systems, including Windows, Mac OS, and Linux. Start by ensuring Python 3.6 or later is installed. Using pip, the Python package manager, you can install Ray with a simple command, pip install Ray. Once installed, configure Ray by setting environment variables tailored to your system's resources. If you encounter any issues, Ray's community forums and documentation are excellent resources. Finally, verify your installation by running a test script. Congratulations, you're now ready to scale with Ray. Ray tasks are the fundamental building blocks for parallel execution in Ray. By using decorators like at ray.remote, you can transform regular Python functions into Ray tasks, allowing them to execute concurrently across multiple nodes. This parallelism is key to accelerating computational tasks. Once tasks are defined, you can execute them using the remote method and retrieve results with ray.get. To optimize performance, consider task granularity and resource allocation. Ray also supports task dependencies, enabling complex workflows without the need for cumbersome code. With Ray, executing tasks is both efficient and straightforward.
Ray actors are designed for stateful computation, allowing objects to maintain state across tasks. By using actors, you can model real-world entities like databases or machine learning models within your distributed applications. To create an actor, define a class and use the @ray.remote decorator. Actors can then be instantiated, and their methods called remotely, maintaining state between calls. This approach is ideal for long-lived processes and resource-heavy computations. Managing actor lifecycle and state effectively ensures robustness and reliability in your applications, making Ray actors a powerful tool for stateful distributed programming.
Ray's ecosystem includes powerful libraries tailored for machine learning. RayTune, a library for hyperparameter tuning, enables scalable model training by distributing trials across a cluster. Ray Data provides tools for distributed data processing, essential for handling massive datasets in real time. Integrating seamlessly with frameworks like TensorFlow and PyTorch, Ray amplifies your machine learning workflows, allowing you to focus on innovation rather than infrastructure. These libraries are used in various AI applications, from recommendation systems to autonomous vehicles, showcasing Ray's contribution to cutting-edge machine learning solutions.
Efficient resource management is crucial in distributed computing. Ray provides a comprehensive framework for allocating and monitoring resources such as CPUs and GPUs. By declaring resource requirements in your Ray tasks, you ensure optimal utilization of your cluster. Ray's dashboard offers real-time insights into resource usage, helping you identify bottlenecks and scale resources dynamically. However, managing distributed resources comes with challenges like load balancing and fault tolerance. Leveraging Ray's built-in features and best practices can help you overcome these challenges, ensuring your applications run smoothly and efficiently. Debugging distributed applications can be complex, but Ray simplifies this process with a suite of tools. Ray's dashboard provides a comprehensive view of your application's health, allowing you to monitor tasks, actors, and resource usage in real time. For debugging, Ray offers detailed logs and diagnostic information, helping you identify and resolve issues efficiently. Common debugging scenarios include task failures and resource contention, each with documented solutions. By adhering to best practices, such as setting appropriate logging levels and testing at scale, you can maintain the robustness and reliability of your Ray applications. Ray's impact spans multiple industries, from tech giants to research institutes. Uber uses Ray to power its real-time data analytics, improving ride-sharing algorithms and customer experiences. Amazon integrates Ray into its data pipelines, optimizing performance and scalability for large-scale operations. In the realm of AI, researchers use Ray for distributed model training, achieving breakthroughs in fields like natural language processing and computer vision. These success stories not only highlight Ray's versatility but also provide valuable lessons in leveraging distributed computing for innovative solutions. The future of scalable applications is bright with Ray at the forefront. As we wrap up, let's recap the transformative power of Ray in scaling Python applications. From distributed computing to stateful computation and scalable machine learning, Ray offers a comprehensive toolkit for developers. I encourage you to experiment with Ray, explore its libraries, and push the boundaries of what's possible. For further learning, check out Ray's documentation and join the vibrant community of developers. If you found this video valuable, please subscribe, share your thoughts in the comments, and let us know what topics you'd like us to cover next. Together, we can continue to scale new heights with Ray.